So today we have a problem to 09 minimum size subarray sum. So we are given an array of positive integer and positive integer target. Return minimum length of a subarray where sum is greater than or equal to target. If there is no such subarray, return 0 instead. So brute force approach, as you probably already figured out, is to try each left for each left boundary we find the smallest integer r such that subarray sum from L to R is greater than or equal to target, and we do this for all of them, for all else, and that's n squared. Now what we can realize is that, okay, so let's say we have calculated R for L equals 0, right? So let's say what's target 7, so here, right? This is first minimum subarray. Then we move here. Well, our sum decreased, right? For sure, because we have positive integers. So what could happen? Well, the sum will be less than what we had before. So either we stay here, right? If there would be like, I don't know, a larger like target would be 8, or nah, target would be 6, no, and whatever. So what happens is that the right borders make up a non-decreasing sequence. So first n log n solution you can do is that you could binary search, because the subarray sum for a given fixed start are non-decrease, are even increasing because we have positive integers. So you could binary search. Another thing you can notice is that the endings of minimum subarrays for increasing L are non-decreasing, which means that we can have like R pointer which just moves depending on if we want. So okay, and then so I kept yapping about nothing for 2 minutes. Yeah, sum can be large. Target is 10 to 9, but yes, I guess we should be fine. So I'm just thinking if we can fit into integer, but we should be able to, because whenever we cross this threshold, which we can only cross by 99,999, right, which fits into int, then we immediately stop. So while Rn and sum target sum plus equals nums target, no, nums r plus plus if sum under target break, otherwise, I mean, maybe I could make it a little more readable, I guess. Okay, and then what we do, well, sum minus equals sum minus equals nums L, and then finally we return ans n plus 1, then return 0, otherwise ans, wait, so ans mean ans r minus L, because I forgot to do that and now I'm missing a semicolon. Okay, I mean, this is the easiest problem of all time. You could see there is 1 million submissions, so probably at least hundreds of thousands of people did this. So sliding window on intuition. let's try to find a smallest integer r such that nums lr sum of is greater than or equal to target. So for a given L, try to find the smallest integer. Okay. Can we find it faster than in linear time? Can we use if we increment L by 1, can we use the previous R to calculate the new one? Question 1. So this is question 2. Now question 1. Since we have only positive integers in the array, we can do binary search over prefix sum, since the subarray sum is increasing with increasing length Q2. If you increment L by 1, can we use previous R to calculate the new one? Can use previous, can use, okay. Question 2. For increasing L's, R's are non-decreasing, therefore we do not have to start searching for R from L every time, rather we can start from its last position. This is just a textbook sliding window problem. Okay, so On, where N is the size of nums, since each pointer is moved through the array, work updating the subarray sum and the answer complexity, space complexity on, since we only use a couple of extra variables. I write this every time if it's O1. Anyways, okay, goodbye.